Greetings, folks. Welcome. In some different videos, we talked quite a bit about the normal distribution. The normal distribution is characterized by its mean and standard deviation, and they all have the same shape. That is, they're symmetric, bell-shaped, and single-peaked. Here's a picture of a normal distribution. Again, it's characterized by the mean and standard deviation. So the center of this distribution is at 55, which is its mean, and the spread is described by its standard deviation of 12. We can go from a normal distribution to a standard normal distribution by transforming the variable into its z-scores. So to calculate a z, you take the value of the variable, which is indicated by xi, you subtract from it its mean, and you divide it by the standard deviation. So a z-score tells you how many standard deviations you are above, and that's if you have positive z-scores, or below the mean. That's if you have a negative z-score. Here's an example of standard normal curve. The standard normal curve has a mean of 0 and a standard deviation of 1. And to find the percentage of observations that you have under parts of a standard normal curve, we use the standard normal table. This shows the cumulative percentage of observations that go up to the z-score. So here's an example of a standard normal table. You see down the first column the z-scores, -3, -2.9, -2.7, etc. And across the first row, you see 0, 0.01, 0.02, etc. Here's an example of how we can use a standard normal table. So let's say we're interested in the percentage of the distribution that is less than a z-score of -2.04. So we go down that first column to -2.0. Then we go across that top row to 0.04. So that combination gives us -2.04. And the cell highlighted in red shows us that about 2% of the distribution is to the left, or that 2% of the observations are less than a z-score of -2.04. We can show this on the standard normal curve. So here you see the standard normal distribution. Of course, the center of it is 0. You can see the z-score off to the left a little bit, which is -2.04. So under the curve, up to that point, you have about 2% of the distribution, or more precisely, 0.0207. Now let's move to the t-distribution. It has a center of 0, just like the standard normal distribution. It's symmetric, bell-shaped, and single-peaked. So far, the t-distribution sounds a lot like the normal distribution. Something a little different for the t-distribution is that its exact look really depends on the degrees of freedom. I'll show you what this means in a sec. Here's the t-distribution with 5 degrees of freedom. Now before I go to the next slide, I want you to look at the axis where you see like the 0, 2, and 4, and sort of focus between the +2 and the +4, and watch what happens. Bam, it just went down a little bit. There we moved from a t-distribution with 5 degrees of freedom to now you're looking at one with 10 degrees of freedom. So watch, I'm going to show you what happens next. Here's a t-distribution with 25 degrees of freedom. So what you're seeing here is that the tails are getting smaller. Now we're going to jump up to a t-distribution with 50 degrees of freedom. The tail gets smaller yet. Now finally we'll look at a t-distribution with 75 degrees of freedom. And it barely moved. It'd be hard to detect. Just like we use a standard normal distribution table to find area under the standard normal curve, we use a t-distribution table to find areas under the t-distribution. Here is part of a t-table. Unfortunately, I can't show it all. There's just not enough room on the screen. But you could find a t-distribution table in any statistics or econometrics textbook, or you could even do an online search using the keyword t-table. The first column is degrees of freedom. So at the top there, it's DOF. Going down that first column, it's 1, 2, 3, 4, 5, 6, 7, etc. Across the top row, you have values like 0.2, 0.1, 0.05. And those values tell you the area in the upper tail of the distribution. So again, this is just part of a t-distribution table. Here's a t-distribution table. It's just continuing. So here you see degrees of freedom like 11, 12, 13, 14, etc. And then here's one where we're starting at 56 degrees of freedom, and then 57, 58, 59, etc. So let's say you were interested in a t-distribution with 59 degrees of freedom, and you wanted to know the value that corresponded with 2.5% in the upper tail. So here, if you look at the t-table, I've got 59 degrees of freedom highlighted in red, and I've got that column that's headed by 0.025 that's also highlighted in red. And where those two things intersect, you see 2.001. What this tells us is that a t value of 2.001 corresponds with the 2.5% in the upper tail if you have 59 degrees of freedom. Here's another example. Let's say you have 25 degrees of freedom and you want to know the t value that corresponds with the top 20% of the distribution. Well, that's 0.856. If you want to know the t value that corresponded with the 10% in the upper tail, that's 1.316. If you want to know the 5% of the upper tail, it's 1.708, etc. And if you ultimately want to know the top 1% of the right tail, that would be 2.485, and just 0.5% in that upper tail would be 2.787. Here's a picture of a t-distribution with 25 degrees of freedom, and we're showing the t value of 1.316, and I've filled in here that is the upper 10% of the distribution, or that right tail. Now, if you want the 5% in the right tail with 25 degrees of freedom, that value is 1.708. Something to point out here is that the t-distribution is symmetric, so if you wanted to know the t value that corresponded with the 5% in the lower tail, all you have to do is put a negative value in front of that 1.708. So the 5% in the bottom tail, or the left tail, is minus 1.708.